Welcome, everybody. Tonight we're working on the Unit 9 exercises that cover objects and classes, and we're starting with exercise 9.4. And this one here has these instructions, and it says, implement a class address. An address has a house number, a street, an optional apartment number, a city, a state, and a postal code. Define the constructor such that an object can be created in one of two ways: with an apartment number or without. Supply a print method that prints the address with the street on one line and the city, state, and postal code on the next line. Supply a method called comes before that tests whether this address comes before another one when compared by postal code. And so we're going to go through this whole process, and we're going to begin, right, because we're going to build classes and objects. We're going to start first by building the class file, the blueprint, right? You don't build a house until you have the blueprint, right? And, one of my standard analogies is, and you guys hear this every time you take one of my classes, is like, if I want to build a house, I don't just run down to Menards and buy a bunch of 2x4s, a hammer, and some nails and get busy, right? I start with a plan first where every detail is worked out. And then I know exactly what materials to buy, how much of those materials, and even what kind of nails to use. It's all worked out. And so you start with the blueprint always. So I'll keep these instructions handy, but I'm going to go ahead and get a Spider up and running here, and then we'll start to write this code incrementally. The interesting thing about building this, right, and we are going to build this as two separate files. So we're going to write one file that's going to be the class file, and then we're going to write a separate file that's going to run the code, right? And so one interesting thing, we probably didn't say this maybe at all during the Kahoot, and I don't think I said it too much during the lecture, is that a class file is not built to execute code. It's only built to construct objects, and that's kind of a weird thought when you start to think about it. So, hey, wait, I'm going to write Python code that doesn't execute code. Yep, that's what we're going to do, by the way. All right, so what I'm going to do here is I'm going to begin by saving this file. I'm going to have to do a little bit of file management first, right? So I got to find the spot where I normally put my stuff as I do my save as, and this is going to be in my fall 2025 semester. And I'm going to make a new folder for Unit 9. So for this unit, everything's going to end up in one folder, by the way. And then this, now instead of calling it like exercise, whatever, like I normally do, when I create a class file, I got to name the class file to match what my class is, right? And that's not a rule, by the way, but it's a convention. And so since I'm going to build a class called address, I'm going to build a file also called address, but I am going to name it all lowercase, right? So I'm just creating a file called address.py. All right, so here's the beginning of that file. And if you wish, and a lot of people who create class files often will put in, and I'm not going to call this ASCII art. This is really just comments, right? To just kind of tell people when they look at the class file, what is this all about, And what I am going to do also is I'm going to start with my class declaration. So I'm just going to call it class, and notice capital A here. Even though my file name is lowercase, the class name, the convention is to use capital letters. And then notice how it indents. So all the code that's part of the class will be indented one level. There's kind of this standard thing that Python programmers do as well. And this is not something you need to add to your program, but you might want to consider doing so. Whenever we build a class or a function or whatever, it's not unusual for Python programmers to leave a footprint of what the class is about and what parameters it expects to receive. And so you notice how verbose this is, right? So it tells you what the class does. Constructs an address with or without an apartment number. And then I have a list of parameters. So this is my incoming data to even build the object, right? So a house number, street, apartment, city, state, and postal, right? But the apartment number is optional because let's think about it. Not everybody's address has an apartment number. Some do, some don't. It just depends on your living situation, right? So this format, right? We often preface our classes with it and our functions as well, just so that once again, if you're working like at a professional place and you're working with a team, other people might want to know what the heck you're doing, so you tell them. Basically is what it's about. Also, if you want somebody else in the future to maybe use your class file or look at it, it's helpful. Or if you step away from it for a month, a year, or 2 or 5, and you come back to your code, you're like, oh yeah, I remember this, because you left a note for yourself and you know what you were doing. Now, when we do build any class file, we typically will start with the init method, right? Now, double underscores here, init, and double underscores again, and then parens. Inside the parens, the first parameter always, regardless of if you're sending data in or not, is the self parameter, which refers back to this object that we're going to be building with this class. Then I'm going to create a list of all the parameters I see above. So it's kind of like a cheat sheet here too, right? So I'm going to add a parameter for the house, which is the numeric part of the address. The street name, like, I don't know, West 42nd Street or something like that. The apartment. And of course, this is going to be optional. You know what? I'm going to leave that off right now because that confuses me a little bit, right? But either way, there's going to be a city, there's going to be a state, and there's going to be a postal code, right? Even in other countries, they have postal codes, right? And then, okay, I got to deal with this apartment thing. And here's kind of an interesting way that Python deals with this. Like if I want to take the apartment, data field or property or whatever you want to call it, internal variable, and I want to have a default value set for it, well, a good default value, if it's optional, would be blank. So that's what I'm doing here. If it was something else where maybe, everybody's got the same apartment number, you can put in a value, right? But here I'm going to leave it blank. So this will make it optional. So meaning if I send that data in that spot, great. It'll use it. If I omit it, it won't break anything. Please notice that just like all of our other functions, there is a colon there, by the way. Now we're inside the init function, and then basically what we're going to do is we're going to grab each one of these variables. So this will be incoming data from a different program, and then we're going to assign them to the variables inside the class. So the typical pattern, right, and this is kind of like by Python convention, is a lot of programmers will do it like this. They'll use an underscore and then the name of the variable, and then they'll set it equal to the incoming data. Right. Now, I can also, and a lot of Python, especially modern Python programmers, just do this, and that's fine. And by the way, I think for the sake of example, I'm going to do it the more modern way because I see a lot more programmers doing it now. So I'm just going to use that approach. Right. If you watch my older videos, by the way, I don't use it, but I do want to make note of the fact, for example, or you can say self dot underscore house, right? And I'll say the old convention, for doing it. And yeah, I'll make the screen a little wider here. Right. And then of course, what you're going to do is all the rest of these, you're going to do the same pattern, right? So I have those pre-created, so I'm just going to paste them all in. They all have underscores, but I'm going to get rid of them, right? Oops. That autofill pops up every time. A little annoying. Now, interestingly, if I were to omit the self part, right, will Python throw an error? Isn't this weird? It doesn't even throw an error. Depending on the environment you're working in, it will or will not throw an error, but you should include the self thing to make sure it's correctly assigned. Now, the interesting thing, like if you're correlating this to other languages, right? And I always correlate to Java and C# because those are other prominent languages here at Gateway. When you do data fields inside of a class structure, you usually list them up here at the top, right? In Python, the convention is you place them in the init function, whether they're preset or you're setting them from outside with parameters. It is still possible in Python to do this. So I can just create a variable called whatever and give it a value up here. And then all of my objects will have a variable called value or with a, whatever with a value in it, right? So this is a way you can do it too. Highly not recommended though, right? And generally avoided in Python. Other languages, oh yeah, go, they do that a lot, right? That's just how they do it in other languages. Okay, so that's our init function. So when we create the object, the external code will come here, ask you for those pieces of information. Apartment is optional, and then it will build those variables inside the object. And then once those variables are set, they travel with the object. We were also asked to create a method. And if you look at the instructions, and I forget what they called it, so they say supply a print method that prints the address with the street on one line and the city, state, and postal code on the next line. Okay, so that sounds pretty simplistic, right? That's just a bunch of print statements, but we'll create that as a method, and I'm going to call it. I'm not comfortable with the name print. Why? Well, that's a reserve word, right? So print address would be one way to do it. Another way to do it, right? And so is if you want to use that str method, that's a way to do it, right? Now, the str method's kind of an interesting one because basically the way that one works is I can just take the class, or excuse me, the object, put it in a print statement, and it'll give you all the data. And you know what? I'm going to create both. So I'm going to create the string method, right? And we'll basically use the same code for it, right? It does have to have the self-referring in it. But think about this. If it's just outputting data to the screen, do I need to send any data to it? No, it's just going to read the data in the object and then send it back to us. And I do have a pre-configured statement here. And actually, I guess it's time to re-engineer it because I'm looking at how I did it. And yeah, I don't like it. So I can print self dot house. So we need the numeric address. And then we also want to print out the street, right? And so, wait, I should use string interpolation here, right? So let's do the f string thing. So that'll go inside a curly bracket. So we'll print the numeric part of the address, a space, and then we'll print the street. So like, West North Avenue, for example. So that would be self dot street. All right. Now, if I want to add the apartment number, well, I guess I could put the apartment number here, but there's kind of an issue with that one because we don't know if it's going to be there. And sometimes it's better if you have the apartment number on a separate line because it makes it easier for your mailman to get the mail to you, right? So I might actually write an if statement here, and I would say something like if self.apt for apartment does not equal blank, then I can display it, right? So then I would just say print, and then we'll do our f string thing. And then I would just say, well, I guess I could say apartment number. And then inside the curly brackets here, I would just say self.apt apartment. And I don't know if I really need the little pound sign there, whatever, doesn't matter much. If the apartment thing is blank, it'll just skip this if statement. It won't print it at all, which is fine, right? Then we'll have the next line, once again, an F string. And then here we will print what? We'll put city. So we'll say self.city. And then usually put a comma after the city and then a space, and then self.state, and then a space, and then self.postal code, right? Except it's just called postal here. So then there is the string method, right? So in other words, when I write code in the other program and I just say print whatever I named my object, this will come up on the screen. Pretty clever approach. They also want us to make this, I mean, the instructions are pretty clear. They want us to define a print function. And I would say that's kind of like the default print function, really. But we can also create one called print address, and I'll demonstrate both of them, right? That'll also have the self-referring parameter, and we'll just have it do exactly the same thing, right? Just to show you two different approaches to kind of doing it. It'll do the same thing. All right. And, you know, if you want to put little headers, you know, on these, I suppose this one should get the header. And what I mean by the header is just comments that tell you what it does, right? And then this one, you could say the default string method for just outputting an object. And really, I would say, and seeing what's in it. You know, that's usually how we use it. It's like, hey, what's in that object? I forgot. Okay, you just use the string method and it just shows you. But nobody says that you can't make it pretty, right? It doesn't have to be ugly. It can be very fancy, and it can do math and it can do other stuff. And I'm going to say here, this is optional and can replace print address below. And really what I'm showing is the string method, just so you guys have an understanding that it's kind of standard in Python code. Another thing that we were asked to do is basically this task. So I have it written out as a comment, so I'm just going to paste it in. And the task is determine if one address comes before another by postal code. So for example, if I live in New York City, my postal codes start with the number 1. If I live in California, my postal codes start with the number 9, right? And the US is set up that way intentionally, right? Also, if you get to the middle of the country, like here in Wisconsin, they start with 5s. And then as you go north, the numbers grow, and as you go south, the numbers shrink. You know, it's all pretty weird, but there's a system to it that's actually very learnable. And kind of like when we say one address comes before another, you know, I might throw in an address from New York City, and then that would come before the address in California because the zip code, you know, or the postal code starts with a lower number, right? So when we're going to do the comparison of the postal codes, how do we extract that from one address or another? Well, we have to actually send the whole object to the method inside of this class. So that's what we're doing here. And so we were told to name this comes before. Okay. And then once again, in the parameter list, we always put the self-referring, and then we're going to call the variable other, meaning the other address we're sending in here. And then we'll compare that other address to the one inside here. We can do that with one super simple statement, because think about it, the postal code in the US is a number. And so therefore, I can just check the postal code inside this object compared to the postal code of the other. And if it is less than, the one internal is less than the other, then I will get a true back up on the screen. That's what it's going to say, right? So if you don't like that, right, you can use a different approach, but you can make it more verbose if you wish. But this will just give us a true or a false. So we'll run the code, comes before, it'll send back a true and false, and then the program running it will display it on the screen. All right. So this is the completed class file. So I'm just going to scroll through it from top to bottom. So here's the init function, the string method and print address, which are identical, and then the comes before function. We're going to go ahead and do a save on this. And I do want to demonstrate that this code will not execute. So when I hit the run button, okay, nothing happened. Why? Because it's not built to run code. This is a class definition. It's a blueprint. It's not the house. It's the blueprint. Right. So now we need to build some houses, right? Or build some addresses, actually. So create another new file. And you can call this really, truly, whatever you wish, right? The pattern of the author of our old textbook, he would always call it demo address, and I'm kind of compelled to use the same approach. But if you want to call it something else, that's on you, right? I am going to do a save as, though, because that's always a smart move as a first maneuver. So I'm going to call it demo address. Right. This will have executable code in it, by the way. And first thing that we can, or not that we can do, but we want to do, is to import the file, the address class file, into this program. So I'm going to say from address, which is the name of the file, import the address class. Just like that. So from the address file, import the address class. Now, just with that simple line of code, we have access to everything that's here. It's all available. All we have to do is call it. All right. The next thing that we want to do, this is per the instructions from the document, is we want to construct a couple of addresses. And so let's do that. Okay. And the way that we do it is we have to think about what we're calling each address, right? We can give it any name we want. It's usually good to have it be meaningful. And so, for example, I might say my house, right? And then normally, remember, if you're constructing something, usually you call the constructor, which is the class file with parentheses, but our class requires all of this data, right, in order to build. And if I omit that, will it run? Well, I guess the only way to find out is let's run it, right? Nope, it won't run. It'll throw an error message. And notice what it says in the error message: missing 5 required positional arguments: house, street, city, state, and postal, and optionally apartment, right? So I got to include that information here. So what I did last time is I added these pieces of information. And so 1313 is the house number, Mockingbird Lane is the street, Racine was the city, Wisconsin was the state, and 98745 was the zip code. Notice no apartment number. It's optional, right? Well, the Munsters didn't have an apartment. They just had a house. Right? That's where I'm getting that. Well, that's not that wouldn't be accurate though, zip code wise, would it? What would be a more realistic zip code, like 53403? How about that? We'll use the campus zip code. That's a more realistic one. Then we would make another version, another copy, and maybe we call it your place, right? And that one also must send in information. But with this one, what I did is I did put in an apartment number at the end, right? So 1200 Elm Street, Kenosha, 53140, right? Apartment 12B. I don't know if that's a real address, probably not. Right. So now we get to play with it. So these two lines build the objects. And interestingly, in fact, let's play with it just the way it is, right? And you notice that range is fine. So these objects are now technically in memory. And I want you to notice up here in the little panel, right? They show you that these objects are now in memory. They don't show you any of the details of it, right? So this is really weird. If I go to print my house, this is what's going to happen. It's going to go to the class file and look for a string method, right? And if the string method is there, it's going to output it. So watch what happens. Oh, it returned a non-string. Okay, so that my bad. Okay, I did it all wrong. All right, so here's what we have to do as a fix. Let's make the string method. It wants me just to return the string, and I put in other stuff. All right. So what I could do is this. It wants me just to return a string. You guys are catching like what the message is. So I'm just going to return. I could spell it, return. And we are going to use the F string approach here, but I'm going to throw in things like \n, and then we'll get rid of all this stuff. City, the state, and the postal code. And now that's all part of one statement. Okay. I am missing the apartment number here, so maybe I'll just add self.apt. I don't know if that will fail, but actually it'll come back as an empty string is what will happen. Okay. So that's the, yeah. And so I would strike this line here. Yeah. So it doesn't become optional, but this would be the default. So let's save this. Let's come back here and try to run it. And then you'll notice what it's doing. Now it's just outputting it, showing you what's inside there. If instead I want to use the print address approach, then I call the method by name. And I want you to notice when I hit the dot after the name of the object, it sees my methods in the object and all the data fields, right? It sees all of it. And so I can just bring that in, and then I can run that, and then you'll notice it does the same thing, right? What's none? I don't know. I got to go back and look at my class file. Where did that come from? Right. Yeah, I'm thinking, Jared, that's what I was thinking too. So print address, we got self street, self apartment, postal code. I'm not really sure where that's coming from. Did I miss? I'm looking at all my curly brackets. Yeah, I'm not seeing where it's coming from, honestly. Of course, we can see if it's coming from the if statement. Oops, I'm putting comment marks in front of it. So if I save, come back and run. Interesting. I'm not really sure where that's coming from. Do I have some other code here? Very fascinating. I'm perplexed, real frankly. feel like asking an AI to solve it for me, but I'm not going to. All right, let's not worry about it right now, but let's test the other one too. So like what you can do here, and this is where like the demoing, you know, comes in. So like really what would probably be wiser, right? So you can do stuff like this. My house address is, right? And then of course you could also add a blank line here just to separate stuff. And if you want, you could also output your place, right? So you can do both of them. So let's try both of these. Let's run them. And there you go. Okay, so this is interesting. Oh, why does this one not have that issue? Is it because there's an apartment number? This one's still maintaining that piece of information, and I am really, I'm going to go back here and look at my class definition. Did I screw up my apartment number? No, I didn't. I mean, and I'm looking at my sample code. Yeah, I have no clue why that's happening. How do you like that? Right. All right. Well, it is what it is. Maybe if I put the underscore in there, I don't know why that would do anything to it. Yeah, that makes no sense. Makes no sense to me at all why it's doing it. So I'm gonna have to like figure that one out later. All right, let's just keep moving on here. And the next thing that we need to test is that other feature. And then I would just put in a print statement like this, just so you know what's going on. Oops, sorry about that. And then to run it, all you have to do is basically, and this is kind of interesting. So we're just going to go put this all inside of a print statement, which is kind of weird to do. But I'm going to say my house, which by the way has that method built in. Does it come before, right? Comes before. So I'm just going to call it comes before. And then what's the other address? Well, your place, right? So here we're sending the whole object over. It's going to go into that object, read the postal code, compare them numerically. And so does my house come before your place? Well, what's the answer? This is 534 and this is 531. So Kenosha comes first. So it should say false. False. Then, you know, if we change this and we say, I don't know, Los Angeles, California, and I'm not sure of zip code out there. It was like 90210 or something like that, right? Wasn't that like a TV show or something? And then you run that one. So Racine does come before that one. Right, so that's the demo on this one, folks. All right, let's take a break. We got a few more to code. So we've been going for a while without a break. Let's do 5 minutes and I'll see you guys then. All right, for the next exercise here, which is exercise 9.5, they want us to implement a class called SodaCan with methods to get the surface area and the volume of the soda can. In the constructor, supply the height and the radius of the can. So notice how like really straight ahead and simple this is. Very interestingly, you know, if you think of what a soda can looks like, right? It's basically a cylinder, right? And a cylinder is basically like two circles, you know, that are of the same size and it's got a height and it's really kind of like a 90-degree shape. And, you know, if you don't know the formulas, by the way, Google will give them to you. So if I'm looking for the surface area of a cylinder or the volume of a cylinder, both of which are asks here, we can just come here and utilize the formulas that they have. And our job as programmers, once again, is the formulas are given. We just have to convert them to Python format. I will have you notice that because we're dealing with circular shapes, pi is in the calculations, right? So we have to bring that into the mix when we create our class file. So I'm going to begin by creating a blank file, and we're building a soda can. So that's what I'm going to call my class file. So I'm going to do a save as here and call it SODA underscore can, soda can. I'll zoom in here a little bit, get rid of all this stuff right here. And then I'll put in a little descriptor here at the top just to kind of be nice about it. And then because we are going to be using pi, we could use an approximation for pi, but we can also import it from the math library. Kind of the same way we import other things. So this is kind of interesting. This is not the program running it. This is the class file. So the class file can do imports too. Right? So the class file is going to use the pi formula from the math library. We are going to define a class. I'm going to use the keyword class, and I am going to call it soda can, capital S, capital C. And then we will build our init method. So double underscore init, double underscore parens, and a colon. And then inside here, of course, the self-referring. And then we were told that the two things that we're throwing in there are the height and the radius. So I'm just going to name it that, height and radius. Okay. Then we want to set these to internal variables, and I'm going to use the other convention here because I do have some curiosity as to why I was getting that none thing in the previous program. So I'll preface it with a single underscore here just to make the names different. Then we need to construct two internal methods or functions, and one is for the surface area. So I'm going to call that one get surface area. And if you watch the lecture video, you guys, I talk about the terminology of get and set and this concept of what we call getters and setters. But get usually means that we're getting information from the object. Set usually means that we're putting information into it. Now, if you think about this, if I have the height and the radius built into the object, I can calculate this. I don't need external information, right? So I will just basically get the formula, and the way that what I did is I actually like copied it from the Google screen, and yeah, the pi symbol actually comes in there, but I can't use that in Python code. So I just got to return that calculation. So what I'm going to do is I'm going to just go right to the return statement, and then inside a set of parentheses, right? And yes, I'm copy pasting for the sake of speed here, folks, as I convert that calculation. 2 times pi times the radius times the height, right? That's 2 times pi times radius times the height, added to 2 times pi radius squared. And so there it is. So that's the calculation. And notice, I don't need to store anything, right? I don't need to put it in a variable or anything like that. Right? We're just sending the calculation back. That's all it does. There's another function that we need, and this one would be to return the volume of the cylinder. So we'll call that get volume. Once again, parens and a colon, and then inside here, the self-referring parameter. Then we'll do the same thing. I have the formula, grabbed from Google, right? And then the return statement, which sends it back. So pi times the radius squared times height, right? I'm not sure of the calculations. Once again, just Google them. There's the volume. There's the surface area. All right, that's the class. That's all of it. So we're going to just save this, Control S to save. And then we're going to write a demo program to run it. So we'll call this demo. Oh, let's do a save as, I guess, first before we call it something. So save as, and we call it demo soda can. If you want to call it exercise 9.5, you can do that. That's fine. first steps first. As we demo this one, we gotta do our import, right? So from the soda can file, we will import the soda can class. Then we'll go ahead and we'll create two cans of different sizes. I came up with the really creative names of can 1 and can 2. And notice I'm hard coding values that I'm sending in. Then I can run, or I can create two variables, one SA to hold the surface area, another one called volume. And then I take the first can and I get the surface area, store it here. I take the same can and get the volume, I store it there, and then I just need to put it up on the screen. And I do have the old argument approach for doing the print statement here, but very easy to convert to string interpolation if you wish, right? And we should just probably do that for future sake because that just seems to be the standard now, right? So we would do that. And then this one, of course, would be vol. And then get rid of this junk. And there they are converted to F strings. So if we run that, gives you the values. Now, of course, what you should do is you should put in 20 and 5 into Google if you want to verify your calculations that it's working correctly. So the surface area, I think the height is 20 and the radius is 5. And no, 785.4. Is that about what we're getting back? 785.39. Yeah, that's right. So you get the idea here that it's working correctly. Now for the other can, if we want to just repeat that process, I can use the same variables, by the way, right? So I can just grab this and repeat it, but we'll change which can we're working with. So this time we're working with can 2. And then we can use the same print statements again to prove that it worked. And then ideally you would verify all these calculations. Oh, yeah, but you got to also change your output here. All right, that would be more correct. There you go. And once again, verify your calculations. So that's the soda can program. All right, let's move on to the next exercise. So we did 9.5, and now we're moving on to 9.6. And this is kind of an interesting one. It says implement a class called car with the following properties. A car has a certain fuel efficiency measured in miles per gallon, a certain amount of fuel in the tank, and the efficiency is specified in the constructor, and the initial fuel level is 0, right? So in other words, we're going to tell it what is the MPG of the car, right? So that is specified in the constructor. That's the only value that we send in. So that's why you see an example of it here. So this car's got 50 miles per gallon. And you're like, what car gets 50 miles per gallon? Well, my old Volkswagen that was diesel and manual got 50 miles to the gallon. And I was talking to a guy tonight at the shop where I took my car in, where his friend's got a Camry that's a hybrid that gets about that, which is very impressive, by the way. Right. Okay. The initial fuel level is 0. We're going to supply a method called drive that simulates driving the car for a certain distance, which will reduce the fuel level in the gas tank. And then we'll have a method to get the gas level to return the current fuel level and an add gas method to tank up. Right. And so notice how these function or method names become kind of control panel-ish, like you're controlling this object, right? So this is kind of a fun thing. All right, so let's get back over here and let's make a new file. Let's do a save as on it, and this is going to become the car class. So I'm just going to call it car. Right, that's what I'm calling it. Let's get rid of these silly comments up here. And then I'm not going to do all the superfluous commenting here, but I'm just going to create the car class, capital C. And I will create the init function. Right, so I'll just include that. We'll drop in the self-referring. And then we're told that the one thing that should get sent in is the fuel efficiency. And this is how I typed it last time. So I'm just following my last approach just for the sake of speed here. And then, of course, that fuel efficiency will get stored in an internal variable. And then we will also set up another variable here that will store the gas level, which will start out at 0. So I'm not sending this in. The car starts out, comes out of the factory with an empty tank, right? We got to put the gas in. Then we'll create another function. And I am, for the sake of speed here, folks, kind of copy pasting, so don't hate me for that. So we'll have one called add gas. And then, of course, what we're sending in is, well, how many gallons did you put in? Right? 5, 10, whatever. It's kind of a good thing to know about your car. How much gas can you hold? Then we'll come up with another method, which will simulate driving. So we'll call this drive. And basically, how far are we going? And so we can figure out how much gas that consumes. So we will take the gas and subtract from it the distance divided by the fuel efficiency, and that'll tell us how much gas, how many gallons we used, right? We subtract that from the gallons we have, and then we'll be left with a certain level. And then we also need to create another method, basically, for just, okay, well, how much gas do I have left? This is like a gas gauge, basically, right? Get the gas level and tell me what it is. I don't want to run out of gas. Right, so this, folks, is the car class, all of it. Grab that quick. Right. Now I'm going to create another new file here, and we're going to call this demo. Spell that right, though. Demo car. Or, if you will, exercise 9.6. Once again, I'm going to remove all the silly comments up here, and then we'll start to do our standard stuff. So first thing we'll do is from the car file, import the car class. Okay. And then, you start looking at different cars and putting in values, right? So like whatever car we put in, it might not be a bad idea to simulate your own car if you have one, right? Maybe look up what its MPG is, look up what its fuel tank capacity is, and then simulate driving at 100 miles and see how much gas you have left. So one thing that I might do is we picked up a hybrid vehicle a little while ago. So I'm going to call this my hybrid. I'm going to instantiate it with an MPG of 27. So this is a car that we just bought recently. The big old SUV, so that's pretty good for a big old SUV. So we're feeding in the MPG. Then for my hybrid, and I want you to watch how I do this here, I now want to add gas to it. So I'm going to call, we got to spell it right. There we go. We want to add gas. How much gas are we putting in? Well, I'm not really sure what it holds. I want to say, I think it's 15 gallons that it holds. So I should probably test that, but all right, but you can look it up online. Let's just say it holds 15 gallons. And then I will tell my hybrid, I'm going to drive it. So I'm going to use the drive method, and I'm going to drive it 100 miles. And then let's see how much gas is left. So with that one, what I would do is I would print my hybrid dot get gas level, and that will tell me how much gas is left. So if I run this, so I gassed up, fed it the MPG, drove it 100 miles, and according to this, I have 11.3 gallons left. And you can do the calculations to figure that out. If you have other vehicles, so I have my old van that I still drive around once in a while. That one only gets 15 to the gallon, but it's a utility vehicle and I can put a lot of stuff in it, right? I can only fit 16 gallons of gas in it, a small tank. Then if I drive it for 100 miles, how much gas do I have left? Well, it looks like 9.3 gallons. The other example I have here, and you can instantiate as many cars as you want here. And this is one, oops, that was used to be my daily driver a while back, but I had an old Volkswagen TDI Golf that was manual, and I would average between city and highway 46 to the gallon. Not hybrid, not electric, by the way, just diesel and manual, right? I only had a 13-gallon tank. Drive that one for 100 miles, and you end up with 10 gallons still in the tank. What I always found fascinating about this car is that 13 gallons, if you multiply that by 46, right? 13 times 46. This is the range of the car when it was full, right? 600, I could go 600 miles on a tank of gas. That's very, very far. In fact, I drove that back from Florida once and I only stopped twice for fuel. Think about that. All the way from Florida. Yeah, crazy. All right. So that was the demo car program, and that was exercise 9.6. We got one more left here, folks. Let's get to that one. That one is exercise 9.10. All right. So exercise 9.10 says implement a voting machine class that can be used for a simple election. Have methods to clear the machine state, right, to get rid of all the votes, to vote for a Democrat, to vote for a Republican, and to get the tallies for both parties. So we can vote, we can clear the votes, we can choose which party we want, and then we can see the results of the election. Right. So we do want to build a voting machine class to start with. So that'll be our first file. So we'll do a save as here. And I'm just going to call this voting machine. Save that. Let's get rid of all this stuff here and zoom in. And I'll start with the class definition. So I'm going to call it class voting machine, capital V, capital M, right? We'll put in our constructor. So we'll define our init function. I'm going to do something kind of clever with this as we kind of work through this. And I'll go through the logic of it first. And I do have to put the self-referring in the parentheses here. So we have to say self. And when we start out, we want this voting machine, like when we first build it, we don't want to have any votes already built inside of it, right? We don't want to favor one party. So we don't need to send data in to do that, by the way. All I have to do is basically declare two internal properties, one for the Democratic count of votes and one for the Republican counts of votes. And when we start, we want it to start at 0. I don't need to send the data in. So as soon as I build my voting machine, it's got no votes built in, right? We're not stuffing the ballot box. Then if we want to vote for any particular party, right? Think about this. If I want to vote Democrat, I just add 1 to the count, right? If I want to vote Republican, we do the same thing. We just call the method. We don't have to send data to it. We just say, okay, there's a vote for Democrat, there's a vote for Republican, and it just keeps adding them, right? And then, of course, if you're gathering votes, it might be kind of nice to see them, right? So we can do this other function, which is to get the tallies. Once again, we don't need to send any data to it. We're just telling it to operate. What's that going to do? It's going to pull back the current value of get tallies. All right. There's one other one that we needed to build, and this is where I'm going to kind of wrinkle our code a little bit. So the one that's left is the one that resets the count. Like, okay, the election's done. Time to clear out those votes. We're going to use the voting machine again, right? And so how do we do that? Well, you set those back to 0, right? But wait a second. Are you noticing the code for resets identical to the code for init? But we don't want to build the object again, right? So maybe the init function, instead of actually running this code, right? And this is where, it's semi-clever, I suppose. I can just have the init function call the reset function internally. And actually the way that you do that is you would say self dot reset. Don't, because what does reset do? Well, what I was doing here before. See how that's kind of a clever approach? Right. So when we create the object, we reset the votes. Okay, we set them to 0. So it's kind of a reset and a set at the same time. All right. That's our class file. Saving it. All right. Let's build a new file here, and let's call this demo voting. Saving it. Let's get rid of that stuff. All right. Let's do our import. So we're going to say from voting machine import. What did I name that? I guess I named it voting machine like this. All right, so there we go. Right. Yep. All right. How many voting machines do we need to create here? Well, just one. If I was a polling place, I might have 20. Right. And then to create it, I just say voting machine with parentheses, right? And that will go in. I don't need to send any data. It's going to go in there, do the reset, set Democratic count to 0 and Republican count to 0. Just that one command. So that builds the voting machine. Then we can go ahead and start casting votes. And this is where it gets kind of fun, right? So I have these pre-configured, mind you. So every time I want to cast a vote for one party or the other, I just go VM, which is the name of the voting machine, vote Democrat, vote Republican, et cetera, right? And then after we do that, then we start to show the results, right? So we might, and once again, I did this with the old school approach, but I could re-engineer this. So let's just type an F string in here. And I would say Democrats and what do we need to display here? So how do we, I mean, really, how do we put the values back up on the screen? And actually, now that I'm thinking that, I think my old approach is actually more clever. Let me just show you what the old approach was, because this will get the tallies. Yeah, let me just drop this whole thing in. All right, so I want you to show you, like, get tallies. What does that do? That returns 2 pieces of information, right? It returns a Democratic count and a Republican count. So using this approach, I can drop the first value for Democrats here and the second value for Republicans there automatically with this one call. So I'm actually kind of liking this approach better than my F string approach, right? Where otherwise I would have to extract each piece of information separately and then put it on the screen. So kind of a clever approach, actually. So let's just run this, see that it works. So we had 4 Democratic votes and 3 Republican votes. Then, of course, it's time for a new election, right? Let's do a blank line here. And then, well, if it's a new election, let's reset the machine. So I'm just going to say reset. So the votes are cleared, right? And then, you know what? Maybe we need a little message here that says that, right? Just so we know, hey, the votes have been cleared. And now we'll have another election, right? So just these are random. I'm just kind of randomly grabbing them from the other screen. I'm not trying to favor one party or the other, right? So here's another election. And then, of course, we can just repeat the code. And I'm trying to figure out like where I'm going with this here. Right. So you would just basically repeat the vote tallies again. Right. So now we've run 2 elections, votes cleared. Here's the new election results. And then, of course, we want to continue on with this process. We would just keep repeating our code here, right? So much for not repeating yourself. So we could probably write code to make this better. But I'm just trying to show you, if you wanted, very, very easy to do this. And I have a little example here. Like, if you don't want to use the same voting machine, by the way, you could create, and this is optional, by the way, you could create another voting machine, call it VM2, and then put a whole bunch of votes in there. You see, I'm trying to mix it up a little bit here, and then run that one. And then with that last one, I had 10 Democratic and 16 Republican. Right. So kind of fun, but pretty basic. But the concept, once again, is that we are building an object that has capabilities, that stores data, right? We can trigger actions within it that do things, and then we can use that information, here to do whatever we need to do. Right. All right. So that completes the last exercise, folks, and that's a wrap here for the evening. So I'm going to stop the video here.